not coming. Amlan.
Can you? Yes, sir. Can you hear me, sir?
Yeah, now it's okay. Now you can speak.
Yeah.
A very good morning to all of you, and welcome to session 2 of day 4 of the online faculty development program on blockchain and smart contract technology, organized by National Institute of Technology, Tiruchirappalli. Our speaker for this session is Ms. Gnana Lakshmi TC, a technology geek, innovator, keynote speaker, community builder, who holds a bachelor degree in computer science from National Institute of Technology, Tiruchirappalli. She is currently associated with Wiley Next as product manager, emerging technologies. She is also a fellow alumni at Women Who Code and started the Women Who Code blockchain community. She is currently involved in a few NFT projects as Solidity developer and is the blockchain architect at the decentralized fantasy game organization Fantasy. She is also an ambassador at various layer 1 chains like Eternity, Algorand, Near Protocol, as well as Covalent. She is passionate about education and technology. Over to you, ma'am.
Thank you so much, Amalan. It's really overwhelming when somebody gives my introduction. I've had my humble beginnings at NIT Trichy, so I'm really, really grateful for Kumar sir for giving me this opportunity to be able to present in the space of blockchain. I've been in the space of blockchain for about 5 years, over 5 years now, and I've dabbled with different types of blockchains, mostly with public blockchains, a bit of private blockchains as well, but I don't have expertise into that. I worked with several layer one protocols, primarily as their ambassador, and I develop a lot of technical content for them in the form of videos, articles, code snippets, proof of concepts, etc. So today I'm going to be, I'm sure you must have heard of common public blockchains like Ethereum and the language used to develop it, that is Solidity. But there are several other layer one protocols that are building much more enhanced features than Ethereum, which not many of them are commonly aware of. So today I'm going to be touching base upon a very important layer one protocol, which has made significant progress since its launch in 2020. And that protocol is called Near Protocol. So let me just talk about the agenda for the day. So since we are going to be splitting the day into two parts, the first part of the day is going to have a brief introduction of blockchain. I know most of you probably already have the insights, but I just want to set the context, right? So you can understand and appreciate why Near Protocol exists and how it is built the way it is built. Of course, we are going to be talking about Near Protocol, some key features of Near Protocol as well. In the post the break, I'm going to be introducing you to an interesting concept called NFTs. NFTs is all the rage today. So I'm sure you're curious to understand what are NFTs, what is the technicality behind them, and how they work. In association with that, I'm going to be introducing, probably not for a long time, maybe about 10-15 minutes, a very small, new, interesting concept called data analytics, or rather understanding the data on the blockchain, right? This has been one of the upcoming recent innovations, that just apart from building decentralized applications, how can you analyze the data that is present on the blockchain, right? And for that, there are a lot of upcoming organizations that are coming, but one of them is called Covalent, and it provides certain APIs which will be helpful for analysis of data. So think of the second part as more like introduction to different innovative concepts in the space of blockchain. That's what I'm going to be focusing on. Two of the main things that we would be talking about are NFTs and data itself. The second half of the day, we'll be working hands-on. I'll be showing you how to write smart contracts, or how to interact with the blockchain, especially keeping Near in mind. We'll be interacting with the Near node, creating some accounts, etc. Fair warning, some of the hands-on labs that I have done, I pre-recorded them yesterday night. That is because my laptop tends to go really slow when I'm coding and running some nodes behind. So I'll be running some of the pre-recorded stuff, but I'll be here throughout the session in case you have any questions. So thank you everyone for joining me, and let's get started. The part one agenda, that is the first half, will be introducing blockchain. We'll be talking about something called the blockchain trilemma. If you have any questions, keep posting them on the chat. And as I take a break, or as we kind of come to the end of the session, we'll definitely have 15 minutes for Q&A, where I'll be taking all of your questions. So we'll be talking about the blockchain trilemma, what is it, and how does it impact the existing ecosystem. We'll be introducing NEAR, key features of NEAR, and some opportunities in this space. Amalan has already given like a really deep dive introduction about me. So I'm an NIT Trichy graduate. I graduated. I did my BTech in computer science and graduated in 2012. That is my highest degree qualification, and I've been in the space of blockchain, as I mentioned, for the past 5 to 6 years. I'm an ambassador at various layer one chains, and if anybody is curious, is interested to do some research, or if you're in general blockchain curious, data curious, always feel free to just reach out to me. I'm happy to help in any way possible. So before we talk about blockchain, right? Let us try to answer a couple of questions in this space. One is, what is Web3? This, I'm sure you must have heard of Web3 a lot. Web3 programming, moving from Web2 to Web3, blockchain. If you have already are familiar with Solidity, you know that there is a library called Web3.js, which is used to interact, which is a JavaScript library to interact with the Solidity smart contract. So what is this Web3? Why are we using this terminology so much these days? Let us take a look at the evolution of how this came about, right? Web 1 was in, I think, early 1900s, I would say. Not even early 1900s, late 1900s, but it's a 1900s phenomena, right? It was the readable phrase of the World Wide Web, right? Basically, what happened when World Wide Web started? There was just information that was available to us on the screen, like Wikipedia. We could go and read the information. We could understand what was happening. Maybe we got some information that was not locally available to us, some international information, but we had the ability to go somewhere and read about this information, right? Web 1.0 was more or less just like a static portal, right? Just static information. There is a portal, you go read some information. Okay, done. That was Web 1.0. Then people realized that it's not enough for me to just read information. I need to be able to, maybe the information is not accurate. Maybe it's not giving, representing something accurately about a fact that I know, right? So in what way can I interact with the web to make sure that I'm able to edit information, I'm able to add information, right? And that's how the Web 2.0, that is the writable phrase of the World Wide Web, came into picture. So this is where your e-commerce boom, people building zillions of websites, selling products on websites, all of this came about as Web 2.0, right? Where people were able to interact with the website. They were able to maybe buy things. They were able to edit data. Maybe they were able to send messages to each other, right? So Web 2.0 was built to enable collaboration and participation. Now you are a part of the ecosystem. Now you can contribute, you can buy stuff, you can sell stuff, you can use the power of the World Wide Web to actually interact with people across the globe. Right? And this evolution, as it slowly came about, has evolved to Web 3.0. That is the executable phase of the World Wide Web as we see today, right? You you not only interact with the applications, but the application recommends to you the way you should interact with it. You don't just go and buy the products that are there today, right? You are getting some recommendation. Hey, probably based on your preferences, this would be a better product. Hey, this is what you bought last time. Why don't you buy this time, right? So now the web is becoming more and more intelligent so that it can, the interaction between the web and the user is a productive activity, right? That's how we are going so much into machine learning. We are trying to understand what all of this data means. There's so much data all over the web. We are trying to understand what it means for a user. How can we enhance user experience 10x times when it comes to the user visiting the website, etc. Right? So now we have applications which are dynamic, right? For everybody, there are websites which may look different for everybody, right? Based on their preferences. Now here, computers have become intelligent. They are able to interpret information. But one of the most important things is there is now abundance of data, right? And we use that data to do what not. And as the data increases, there is something that is missing in this Web 3.0 umbrella still. What is that? We have interactive machines, we have chatbots, we have cool stuff happening. But is there something that you can think of that still prevents you from using a particular website? It prevents you from downloading an app. Is there something that you can think of that would stop you from doing so? You can put your answers on the chat as well. I know this is probably not like a interactive face-to-face session, but if you feel, what is it according to you that you feel still missing in Web 3.2? What would stop you from taking advantage of this amazing revolution, which is, the web world? What is it that you're most careful about when you think about browsing some websites? You can see the chat. Is there any, you can put your answers on the chat, you can type it down. Do you feel there is anything that is stopping you from using any of the apps? Is there anything that is stopping you from going to a particular website? Okay. Okay, I will answer this question. If you thought of it as security, or if you thought of it as privacy, if you thought of it as somebody stealing data from you, or if you thought of it as I don't trust this website, basically, right? So all of this kind of boils down to this single word, trust. You don't trust a particular website to be secure for you. You don't trust a particular website to not play around with your data. You don't trust a particular website to not misuse your images, right? So this is one of the biggest things that is missing in the current Web3 ecosystem, trust. We don't trust certain websites. We don't trust certain technology. We don't know who's behind this technology, who's the centralized power controlling this technology, controlling this website, and what they may do with your data. This is where, in the year 2009, blockchain, the concept of blockchain was an interesting concept that presumably wanted to solve the problem of trust. So, if you see this paper, the Bitcoin paper titled Bitcoin, a peer-to-peer electronic cash system, which was written by one individual or a group of individuals called Satoshi Nakamoto, it outlines a way which is one part of this solving the trust problem, that is being able to transact electronic cash, that is digital cash, from one party to another without the need for an intermediary. So this paper was released around 2009, which was the time, just around that time there was a huge financial crisis, a global financial crisis. A lot of the investment banks in US went bankrupt. People lost a lot of money. And because of this, people also lost something else. That is their trust and faith in a centralized system. There had been a lot of research that was going on to build something like this, where you can transact electronic cash digitally, right? Without somebody needing to come and do the verification for you. Why is this verification required in a digital world? Why not in a physical world? Because we go and buy something, we go and buy coffee, we pay some money to the coffee vendor, but there is no third party required to come and verify whether I actually own the money, how am I earning that? Nobody is questioning me that, right? When I go to a restaurant, when I go to a coffee shop. Why? Because the vendor who's actually accepting the payment is verifying it for us, right? All he or she needs to verify is that I am actually paying that money at that point in time upfront, right? Now, this is a similar, now this kind of verification doesn't ex- doesn't exist didn't exist before this technology or this paper was published, right? So there was a problem called the double spending problem that everybody was trying to solve. That is, in a digital scenario, it is possible for you to easily replicate your currency and spend the same amount of money two times. Or you don't have a robust system in such a way that you are able to, once you spend this amount of digital money in one transaction, you are not able to spend the same money in another transaction. This was a problem that this paper proposed a solution for in the form of a cryptocurrency, digital currency called Bitcoin. So the double spending problem was solved here in this paper. And this is the origin story for blockchain. And while solving this problem, knowingly or unknowingly, this concept of blockchain came about. Okay? So what is blockchain and what does it contain? Blockchain consists of a set of transactions which are clubbed together and combined into one block. I will be showing you an example of this as well as to how the blocks look and how are they all combined together. But think of this as just data that is combined together, and all of this data that is being transacted, all of the value that is being transacted, information that is being transacted is all clubbed together and put into one block. Uh, these blocks are connected to each other with the help of cryptographic hashes, thereby creating a blockchain. So simple. We can visualize this in a computer for somebody who's familiar with how linked lists work, who's a programming enthusiast. For them, it could be set of blocks which represent the different elements of a linked list, which are all connected to each other. So that's basically, simply put, that's your blockchain. Now, there are several things that are play when it comes to a blockchain. It's not just a set of blocks that are connected to each other, right? Um, each of these, it's a peer-to-peer technology, right? That means people are connected to each other. That's what forms the network, the underlying network, the most primary component of blockchain, what we call as the blockchain network, right? What is the network? The network is nothing but set of nodes or peers who are connected to each other. The transactions that happen between these peers get clubbed together and they are put into a block, and each of the transactions that are happening on the network, all of them are recorded into a ledger, right? And a copy of this ledger is present with everybody who's a part of the network, who's a part of the blockchain, right? And that's why it's also called as distributed ledger technology, DLT. You might have heard of this terminology as well while describing blockchain. And it is open source and immutable. So blockchain is open source, as in most of the frameworks that you see, or almost all of the frameworks, including the private ones themselves, are open source. You are able to fork the code, you are able to work with the code. This technology was built with open source in mind, that it should be accessible for people. It was built for financial accessibility. So even from a technology perspective, it is completely open source. It is called, so the second word over here, the open source and immutable, right? I want to show you rather than describe what immutable is, right? So so just to give like a quick idea, immutable is basically you can't change anything very easily. You can't mutate it, right? I'll show you how, so then everything probably will fall into fall together. Decentralization. So why this whole concept was introduced, right? Because when I mentioned about the investment banks crashing, the financial crisis, these are all centralized organizations. That is, there is one entity that is controlling everything in this space, right? That's where your decentralization comes into picture. That is, you're removing the power from one person and distributing it to everybody within the network. So that's one of the that's one of the important properties that sustains this concept of community power, right? Everybody who's a part of the network is a part of the decision making process in one way or the other. And that's what blockchain aims to achieve. So now let's quickly see. Okay. So the blockchain promise, or when you think about why you should use blockchain, what is the problem that it's solving? You should think about immutability, right? It doesn't allow you to change things easily. You should think about transparency when you're thinking from a public blockchain concept. Even in a private blockchain, you should maintain transparency amongst the nodes that are a part of the private blockchain. And the third and the most important is trust. So you trust the network. The network consists of a lot of people, and that brings that kind of trust which is not there in one centralized agent. Okay. So let's take a look at what makes a blockchain, right? So just want to so Um, I'm sure you are familiar with most of these things, but let me just show you like how the pieces are connected, right? Um, so if you see the data that is stored in a block, like we said, transactional data would be stored in a block. But how is it stored? The data is encrypted and stored. This is the encryption. So the data, the hash of the data is being stored. So for example, hello. This is suppose that a data, just an example. You can see that there is an SHE-256 hash that is created out of it. So the interesting thing about these cryptographic hashes are that these hashes cannot be reversed, right? As in you can't easily find out the data from the hash. So that is obviously one advantage for immutability. And the second advantage is something called an avalanche effect. So basically what happens is, even if you change a small piece of data, the hash changes drastically. There is no relationship between the previous hash and the new hash. So the hash changes drastically, thereby ensuring that the hacker, even if the hacker gets a whiff of what some closely associated information, the hacker is still not able to figure out the original data. So I'll show you this avalanche effect. Pay careful attention to what this hash looks like. So for this particular sentence, hello, my name is Gyan. The hash is 029B something ending with 9847. Okay. I'll just remove a small character in this, okay? And I'll just make it, hello, my name is Jin. You can see that the hash has changed drastically. Like, the last four characters of the hash, the first four characters of the hash, they have no correlation whatsoever. The middle ones, they have no correlation whatsoever with the previous sentence, that is this one, right? So this is one of the properties which helps bring about the immutability. So when you see transactional data, you are likely to do value transfers, like A transferred 1,000 bitcoins to B, right? Now, if this is the hash of this, if you just change or add or delete 10, the newly produced hash is completely different from what hash was there earlier, right? So even if you manipulate little bit or try to manipulate some kind of data, the hash will change drastically, thereby throwing an error. So this brings about an immutability. Let us directly go to the blockchain and see how this is implemented in practice. If you see this data, right? Let me just add some random data everywhere. The original data does not even look anything close to this, but this is just for an experimental purposes. Are you able to hear me? Is there any issue? Okay, yeah. Okay, yeah. Sir, you can unmute and let me know if there is any, you're not getting my sound. If there are any internet issues, sometimes I'm also not getting. Okay. So you can see here.
Now it's okay,
Yeah,
but there's some problem.
okay. Okay. Thank you, sir. So here you can see the different blocks, right? Blocks are connected to each other. This is what is your blockchain all about. This is your blockchain, not just in theory, but in practice. So each block will have a block ID associated with it. A nonce. A nonce is a random number that is generated for each of these blocks, which specifically identifies where this block stands in the life of the chain, right? Data, this is going to be your transactional data. Who transacted what? So every couple of transactions that happen, they are clubbed together and put in a block. And that's how your blockchains are formed. Now, this is the first ever block, which is known as the Genesis block. So it's not having any previous block. So the previous block hash is 0. But this hash is the hash of the transactional data along with the other data that is present in this block. Right? So previous and then the present, the current hash. Now this particular block, the second block, again has a block ID, a nonce, some transactional data that will go into this block. It will hold the hash of the previous block, and that's how these two are connected. And it will have its own hash, which is a combination of things, data as well as other things that are present in the block. Now, let's see how the immutability factor comes into picture, right? So when I try to change something in this block, right, the hash of this block will change. And now this block will get confused because this was having some other hash. And as this block gets confused, the next block will get confused, the next block will get confused. And it's a big ripple effect, right? And that's how the immutability comes into picture. So if I remove 1K here, you can see all of the blocks have become red because now everybody started to panic. They are like, we don't understand what just happened, right? And now imagine this in a distributed world, right? One blockchain is one distributed ledger. Now, everybody who is a part of the network will have the same information. They will have the same blocks. They will have the same hashes. Everything will be same. So you can see peer A, peer B, peer C, peer D, peer. So, and now, as we know, many of the networks, they have billions and billions of people across the globe who are a part of the network, right? So everybody sees the same data. Imagine how difficult it is to change something in, if you make a change in a small one. Of course, over here everybody cries, but everybody else who is also having that data will not validate this. They will be like, no, like, what just happened? We have something else, we have some other data, we have some other hashes. So this is how blockchain ensures that immutability is present, right, in your application. So that's why they say that when be very careful when you're writing data to blockchain, because data is persistent. You cannot change it. The only way you can change is by adding another data which refers to this block, saying that the data that was in this block, this part of the data, I want to invalidate that, and here is the original one, refer to this. So this is how the one of the biggest features, that is immutability in the blockchain space, comes about. So we have already looked into what is a block. This is one of the core components of a blockchain. Blocks connected together form a blockchain. Now, whenever we think about blockchain, we are talking about this entire ecosystem. There are two major questions that we ask. One is, how is blockchain immutable, right? And second is, who selects the next block? You're saying that you create where you have transactions are clubbed together, blocks are created, then you connect one block with the other. But who's actually selecting the next block? Who is selecting which transaction should go into which block, and which block should actually go onto the blockchain, because there are so many people, right? And we say that everybody has equal power, everybody has the ability to participate in the creation of this blockchain, right? So who actually selects the next block? For the first question, we already have an answer, right? How is blockchain immutable? We just saw that. It is almost impossible. That's the thing. It's not impossible. It's possible to change the data, but it's almost impossible to do it because of the sheer number of people who are a part of the network, right? As well as the hash change. Now, who selects the next block? This is where another important concept of blockchain comes into picture called consensus protocol. You might have heard of it in various things, in various formats, maybe consensus algorithms or yeah, consensus protocols or just consensus, right? So consensus protocols are the way using which consensus is basically an agreement, right? You consent to something, you say yes or no. So consensus protocols are basically the rules that are set for that particular chain, for a particular chain, using which you determine who and how should the next block be selected. How should the next block be selected and who should be doing it, basically, right? So that's the consent. Those are consensus protocols. Consensus protocols broadly fall under two umbrellas. One is a proof of work, and another is a proof of stake. Quickly, I'll walk through this. Proof of work requires the user to do some kind of work in order to be able to add a block to the blockchain. So what do? They solve a very, very difficult mathematical puzzle, right? And if you are able to solve that puzzle, then you are eligible to add the block. So whichever transactions you have picked, you are eligible to add that block to the blockchain if you are able to solve that extremely complex mathematical puzzle. Now, the issue with the proof of work is that this extremely complex mathematical puzzle requires a lot of computational power to solve that puzzle. And the more people that join the network, the difficulty of this computational power increases exponentially. So that is why you see a lot of people talking about why Bitcoin is bad for the energy ecosystem. It is because it is a proof of work based chain. So miners are the ones, we call them miners because they are mining for coins. Um, Miners are the ones who are solving this extremely difficult mathematical puzzle. And once they do solve it, they get some Bitcoins as an incentive and they are able to add the block onto the next, on the chain itself. And as this requires a lot of energy consumption, there is another consensus protocol, umbrella concept called proof of stake. So as the name suggests, here, you don't have to do any work. You don't actually have to solve any. You may have to solve smaller puzzles, but they may not involve as much work as to the magnitude of proof of work. So what happens in proof of stake is that the block creator, right, is chosen by an algorithm based on the user's stake. So how much stake do you have in the system? That is, how much portion of the tokens of the currency do you hold in that system? Your voting rights or your ability to be the block creator will be proportional to that. Um, there is no reward as such for mining a block because there is no mining happening. So those who are creating the block, those who are block creators, they will also be getting some kind of transaction fee they will get as incentive. Right? Now, these block creators in many ecosystems, what are they doing? What do you mean by creating a block? You see these transactions on the network. You actually validate whether those transactions are correct or not. What do you mean by validating? If I'm sending 10 BTC to Kumar sir, then you need to validate whether I actually have 10 BTC. I can't just send 10 BTC out of the air, right? You need to also validate that I own a proper wallet. I'm sending it from a proper wallet address where the 10 BTC exists. And you also need to validate if the address that I'm sending to is actually another proper Bitcoin address, right? It could be some other validations depending on the network as well, right? But all of these validations somebody needs to do. Who does that? The miner or the block creator, right? In the consensus protocol situation. That's why the block creators in many ecosystems are also known as validators. They actually validate the transactions. They put them together and then they form a block. Right? So between public and private blockchains, I have this pointers. I don't think it's important. Let's just skip this. Let's go to this. So now that we are like through with all the basics, let's talk about one particular blockchain that we want to focus today is public blockchain that is permissionless. That's the ecosystem I come from. So a permissionless blockchain is a decentralized database which can be read by all, it can be written by all, and it is immutable by all, for all. So that's why it's called a public blockchain, right? All the data, all the transactions are visible on an explorer. You can go see what happened. You can see who owns how much in their wallet. But you see, the who is not a name. The who is an address. Which address owns how much of which token? All of this is visible on a public blockchain. So it can be read by all. It can be written by all. That means you have the ability to join the network, you have the ability to create decentralized applications. Anyone and everyone can do that. It is immutable for all. So the immutability remains the same for everyone. Now that we are familiar with how blockchain works and a little bit about the consensus protocols, the blocks, etc., right? Let us try and understand what are the challenges in this ecosystem. So one of the primary challenges, which is put together very beautifully in the form of the blockchain trilemma. So the blockchain trilemma, as the name suggests, consists of three properties. So the trilemma itself is nothing but it's a play on the word dilemma, where you are required when you're building a decentralized application due to the existing constraints, you are required to choose any two out of these three important features for your decentralized application. That's the blockchain trilemma. What are these three features? The first is the scalability, right? The ability scalability is the ability to scale your decentralized application. Security. Create a layer of security from attacks on the blockchain. Right? So if you are familiar with the Ethereum ecosystem, I believe in 2016, 2015, 2016, there was a huge attack on the DAO, and close to a couple of $1 million worth of ETH were stolen, right? Due to some security flaws and vulnerability. So security, of course, is important for your application. And the third is decentralization. That is your solution truly decentralized, or are you still dependent on a centralized entity, right? So it's if your solution is deployed on cloud, that doesn't mean that it's a centralized solution. Are you dependent on someone, right? For So the cloud example, I would still say it has some centralized components because the cloud is again controlled by one centralized entity, your cloud provider. But is the majority of your application decentralized? Are you able to ensure that your application is not controlled by just a few entities of the network, right? So that's your decentralization. In blockchain trilemma, due to several, the trilemma came about for primarily considering the Ethereum network in mind, where there's a lot of congestion, and then the gas price is like shooting and like hitting the roofs. So it is difficult for us to have all of these features in the application, right? And choosing two out of these three is actually not a good practice at all to build a truly decentralized application. If you leave decentralization, then you have only scalability and security. If you leave scalability, you just have a small application. You can't scale it. And if you leave security, then it leaves your application to vulnerability. So it was this blockchain trilemma that kind of provoked other people to think about different solutions that can come into the layer one ecosystem apart from Ethereum itself. So what is the common flaw? So there are, of course, the best choice would be to go for proof of stake, right? Proof of work is too much energy consumption, and proof of work actually, is a little bit of a centralized solution because it leaves the work to be done by just a couple of miners. So in your entire network, if you see, the number of miners would be less than 2%, actually close to 2% would be the number of people who are miners. So the entire networks, um, the power of the network is actually in their hand because they are doing the mining. Similarly, in proof of stake, there are several solutions where they are trying to come up with, trying to solve the blockchain trilemma. But so far, or I wouldn't say so far, now there's a lot of development, but most of them have a common flaw. That is, huge portion of the economy is controlled by the small portion of the economy, which still makes it a little more centralized, right? Um, and the solution to this is where a concept called sharding comes into picture, right? This is a bit of like a deep dive technologically. I will share some papers, research papers with you, should help you understand much in depth about sharding. Here I'll just be covering like a umbrella view. What is sharding, right? uh, so the process of sharding is basically it seeks to split a blockchain network into separate shards, so you have one entire network. Now what is the problem with this one entire network? Why is it not scalable? Why is the throughput so less? It is because in the existing ecosystem, the work that is to be done by the network, it is split amongst all the nodes that are a part of the network, which is not a scalable solution, right? Because all the nodes are constantly involved in finishing that work. Now if you want to add more and more nodes and scale your solution, then the more number of nodes you add, the more time it takes, because you're splitting the work equally amongst all the nodes, right? The solution to this comes in the form of sharding, where you're splitting a blockchain network into separate shards. Each of these shards will contain their own data, which is separate from the other shards. And what this does is, instead of all the nodes doing all of the work, each of the nodes are only doing a subset of the total work. So the more nodes you keep adding, they are still being allocated a subset of the total work. They are not doing all of the work all the time. So there is no congestion, right? You're trying to remove the problem of congestion, increasing throughput, thereby increasing scalability. So if you think of sharding, you can see like there is one blockchain which is split into several shards. Each of these shards contain their own data, and this is how you can add scalability and throughput to your chain, ensuring that your solution is still decentralized. Now, obviously, there are couple of ways you can use sharding. Sharding is more of an umbrella concept. In Near protocol, there is the consensus protocol is called Nightshade, which uses the concept of sharding. Before we go to Nightshade, this is important in to understand how sharding works, right? Now, if you are thinking of, hey, sharding is just splitting a blockchain into smaller blockchains. So each of them would act as individual blockchain. How is that one single network, right? That's where your beacon chain comes into picture. So for each of the shards, you would require that there should be validators, right? Who would be producing the blocks in these shards. But if you think of one single blockchain, let's go back to this. If you think of this one single blockchain and this other blockchain, which is split into shards, there'll be X number of validators for this particular main chain, right? Think, forget about sharding for now. Think of there are X number of validators in the main chain. There is something called a 51% attack. That is, if you convince 51% of the validators, if you convince 51% of the network that certain data is true, right? Then you that data becomes true. Think of it that way. Now, if you split the validators into these different shards, right? And you have already convinced some 51% of the validators here, right? So you need to convince, say, for example, if there are 10 shards, you need to, if each of those shards get those validators whom you have convinced, it is likely that the security of the shards themselves is compromised, right? Because you have convinced them to lie for through whatever, right? Um, Through some hacking or whatever. Now, this is where your beacon chain would come into picture. That is, you can't, the validator assignment is not mapped just like that. Like each shard will be having this particular validator all the time. Shard 1 will have these validators. Shard 2 will have these validators. No. There needs to be some randomness when it comes to assigning the validators to the shard. So both so who creates this randomness and who will do the validator assignment, right? That is where your beacon chain comes into picture. This beacon chain is also known as relay chain in Polkadot. It is called as Cosmos Hub in the Cosmos chain. We'll stick to beacon chain. Beacon chain is the terminology introduced for Ethereum 2.0, which is going to be coming very soon, which is going to be using sharding. So randomness and validator assignment requires computation, which is generic computation. So it's not specific to any particular shard. And for this type of computation, right, there is a separate blockchain known as the beacon chain, which is performing all these tasks. So what are the main responsibilities of the beacon chain? It will be managing the validators and their stakes, and it will be nominating the chosen block proposer for each shard at each step. Basically ensuring that there is randomness in assigning validators and nominating the chosen block proposer for each shard. Who will be the block proposer for this shard at this point? Who will be the block proposer for this shard at this point? Right? That's the job of the beacon chain. Now, what happens in nightshade, that is the particular specific to Near, is that even though it is a sharding system, the whole system is considered as one blockchain. Right? So, how is this structured? Every block will logically contain all the transactions for all the shards, right? So you saw the blockchain. Now the block itself may contain transactions from different shards, right? Each participant, but each participant of the network would maintain the state that is corresponding to only their shard that they validate transactions for. And list of all the transactions in the block is split into physical chunks, that is one chunk per shard. So I'll show you this visually. So a little more. Yeah. So you can see, yeah. So this block, right? Each of the blocks will contain chunks of data. These chunks can be from different shards. So this entire, each of these shards will act as one single blockchain on their own, right? Anyways, so you can see, and the blocks are being connected to each other, same as your main your original concept. So the actual, so even though there is sharding, it is facilitated, it is architected in such a way that the blocks that are created will have the chunks from different sharding put together, and then the blocks are connected to each other to form the blockchain. So this ensures that your understanding of blockchain is remaining the same way, but your data, the transactions inside the blockchain, are actually coming from different shards in the form of chunks. And this ensures that there is scalability and throughput along with decentralization, thereby trying to solve the blockchain dilemma in one of the ways using sharding. So now that I've given you an idea of how the protocol works under the hood, I think it is important to see what the protocol itself is. So we are going to be talking about Near blockchain. Near blockchain or Near protocol is one of the recently introduced protocols with mainnet launch in around May 2020. So it's a fairly new layer one blockchain. So how Ethereum is your layer one blockchain, it's a protocol in itself. Similar to that, Near is a layer one blockchain. It is rapidly expanding, and it is one of both the co-founders of Near actually come from an enterprise background of over, I think, 10 years. They have a lot of MemSQL engineers who are actually building the whole Nightshade part behind this. And yeah, they have been rapidly growing. They're having a bunch of features, which as well as interoperability that they have been adding to the chain. So what is Near? Near is a developer-friendly proof of stake protocol, which uses sharding as the underlying consensus mechanism. It is a public blockchain. It is primarily run by the community. There is also a Near Foundation, which supports community grants, community projects, and other initiatives. It is scalable and truly decentralized. Why is it scalable? Because it uses the sharding approach, which allows the network to increase in capacity as additional nodes participate. So, how does this happen in sharding? When more and more nodes come, they are all given their own responsibility in the form of their own shards, but they are still connected at the top as a blockchain, right? So that's why you're able to increase the number of nodes as well as scale the solution, thereby keeping the decentralization as is. Why Near? So there are a couple of reasons for this, some of which I'm covering here, some of which you will discover on your own as you work with the protocol. But one of the most important things is that the technical design of this protocol is focused on creating the world's most usable and scalable decentralized platform. What does it mean when we say scalable is something we have already seen, right? From a technology perspective, what are we doing to make sure that this protocol scales? You can build more and more applications, right? Now, usability comes from a user perspective. As a user, how easy is it for you to create accounts on Near? How easy is it for you as a developer to deploy applications on Near, right? Both of these are equally important. It's equally important to have a sound technical backing, as well as important to be able to work with it as a user seamlessly. The organization and governance structure are designed to rapidly ship, right? What does it mean by rapidly ship? That is, you're continuously giving out more and more features. You are taking input from the community. You are open to understanding what the community needs, and you're rapidly building those features that the community requires, right? And the protocol is continuously evolving. You can see that the DAOs that they had created version 1.0, there's so much work going on to build a version 2.0. And in every aspect that they're building, they are trying to evolve so that they are able to collaborate with the ecosystem, and they're able to build features that we can use straight away, right? Again, here are some of the things that are going on in the Near ecosystem. So the green image shows that Near is climate neutral, as anyways they are using proof of stake, but they also went to an audit where they were certified climate neutral. Sorry. And the image above this, that is the rainbow bridge, connects is a bridge between Near and Ethereum. So you can move your assets between both the chains, thereby facilitating interoperability. The third and one of the most recent developments is also known as Aurora. So Aurora allows you, Aurora is a development which is EVM compatible, right? It allows you to build your applications on top of Ethereum, with keeping in mind that Near you can use Near for the transaction purposes on top of Near protocol. So you get like a layer 2 experience for Ethereum. So you can see some of the whys are actually coming from an interoperability perspective, right? Are being answered by an interoperability feature that Near is working with the other ecosystems to ensure that people are able to build more dApps. So I'll show you what is the effect of the scalability and throughput on the numbers. Yeah, there's like, so if you see the transaction per second for Ethereum is 15. I think it's a bit more now. But in Near, you can have up to 100,000 transactions per second. Why? Because it uses sharding, right? So it is scalable. The block time is 1 second, although the transaction finality could be 2 to 3 seconds. But in Ethereum, it could take up to 3 minutes, depending on how much gas price you're giving. We don't know how it will change once the EIP, Ethereum Improvement Proposal 1559, is being implemented. It will come in July. But nevertheless, that doesn't change much of how the network itself is congested, because at the moment Ethereum is still working on proof of work. It uses an underlying algorithm called ET hash. So because the network is so congested, it takes a long time for your transaction to be finalized. Whereas on Near, you can see the transaction finality is within 2 to 3 seconds. Most important thing for everyone, the gas fee. How much transaction fee should we pay for a transaction? It's very, very important to us, right? Every time we are building an application, we are making a value transfer, how much are we paying in the form of transaction fees, right? So that's where you can see that the near transaction fee is actually less than $0.01. Whereas in Ethereum, it's $21 approximately. When the network is extremely congested, you may have to pay over $100 as transaction fees. I have done that myself. So Near brings in all these features that will help you build your decentralized applications easily on top of Near. If you do want to build on top of Ethereum and use Near as layer 2, it is possible using Aurora as well. Some key features of Near, right? Some of this we have already discussed. As I have 15 minutes, I want to leave a couple of minutes for Q&A as well. Quickly going through some of the key features of Near. The onboarding on Near is very simple. I'll show you in a bit, maybe in the second half, or if we have time in the first half. You can just create a Near wallet within a few seconds, right? And subscription is very easy. One more thing that actually encourages end users to use Near is that developers can take actions on behalf of their users. So, for example, if I ask you to say that you need to send X amount of Near, so to vote for some product, right? I can facilitate in such a way that whatever you vote, the amount that you would need to send, I can actually give it to you. As a developer, I can create that kind of functionality that I give you 1 year and you can use that 1 year to vote. Developers can do a lot of funky stuff in order to ensure that for a user, the onboarding experience is very, very easy. Familiar usage styles and predictable pricing. This is again, we know that gas prices are more predictable on Near, since it is, because of the underlying mechanism. Fine. Developer usability. So we saw end user usability. End user is not worried about gas pricing or being onboarded on Near. From a developer perspective, the smart contracts can be developed in two languages, Rust or assembly script, right? Both of which compile to WebAssembly, wasm smart contracts. There is robust tooling, as I have shared in the prerequisites. You can install the Near CLI. You have a lot of JS libraries, SDKs that can help you get started with Near. So there is a lot of tooling. One of the questions is, what is the currency in Near? The native currency of Near is Near tokens themselves, NVAR. I'll show you that in a bit as well. I'll show you the wallet and the testnet wallet that I would encourage you all to create along. Developer business model, I don't want to go too deep into it, but basically Near has created a mechanism where developers get incentivized to build their products on top of Near. So part of your transaction fee actually comes back to your own smart contract that is encouraging you to build more. So when somebody else calls your contract, calls the contract function, part of that transaction fee comes back to your contract. So as a developer, you get benefited. Scalability, we have already seen the sharding approach, which allows network to increase its capacity. And this is done by dynamically splitting the nodes into multiple shards when usage is high enough. And then you're parallelizing the computation across the shards. So just to summarize, there is efficient development and evolution in the space of Near. It's a low-cost platform. It's developer centric and it has a bunch of frameworks that we can play around with. And there is an innovative business model for developers and entrepreneurs, as you have already seen. You get incentivized to build applications. Actually, when people use your applications, then you actually get incentivized as a developer. Yeah, this is something that I want to show. Right, and that time. So this is a site called DAP Radar. You can also use it for seeing other chains. But here I'm just showing the top DApps for particular chain. I have chosen Near already. So Near Crowd is actually a very interesting application. Uh, Near, okay, there's a very interesting question. So Near Crowd is basically an application where you can label different data sets and get incentivized for that, right? So there'll be different images. You can I don't know if the tab opens, and you have to wall. Yeah, actually, will have to be added to the different tasks. But basically, there are tasks that you can work with, and you can label certain. Yeah, you can see. Yeah. So basically, you can label these data sets, and this is like the community participating on Near, and you get incentivized in Near for doing so. Like this is like a task. There are different other dApps. There is Ref Finance. Um, Yeah. Near Crowd, there is the Rainbow Bridge that is again being used popularly. Then there is Ref Finance. Something is wrong with this page. There is Ref Finance, which is one of the swap DEXs, decentralized exchange built on top of. Yeah. So this is one of the other popular applications built on top of Near, which is your decentralized exchange, right? Used for exchanging tokens. Then so that there are. I want to show these bunch of other dApps like you have a Berry Club and some other popular apps in the Near space. Let's see. Okay, this. Yeah, okay, cool. So, Refinance is an exchange. Berry Club is a DeFi app. This is again for yield farming, etc. Then we have Paris, which is an NFT marketplace, a popular one. So, Near Names, again, a popular NFT, not NFT. This is a popular app that can be used to give away Near Names. Then there is another marketplace called Pulse. There is Sputnik DAO, and then there is this is a DAO, decentralized autonomous organization, which is very popular, built on top of Near, Sputnik DAO, Rainbow Bridge, then Pixel Party. These are just games. Um, yeah, basically, you can go to DApp Radar and also see what are the different dApps. If you're specifically interested in, say, gaming, DeFi, gambling, exchanges, collectibles, marketplaces, you can see all of these dApps for each of these chains. So what you need to keep seeing is that how many users are coming and using this, and as you can see, there are like a bunch of users who are increasing amount of users who are using these tabs. So you can see that this chain is becoming more and more popular. Of course, there'll be more users on the ETH chain itself because it is one of the most popular ones, but you can see for an up and coming blockchain how this kind of is important to see these parameters as well. So going back, okay. So there is one very interesting question. Starting every node will be having zero currency. How is proof of stake implemented? So proof of stake, so when you think of tokens, right? When you are creating your own chain,
Um, I'll give an example of how we create an ERC20 token. So an ERC20 token can be created. Actually, it's a very simple smart contract that you need to deploy. And whenever you are creating a token, you create something called a total supply of that particular token, right? And the initial total supply, you mint it to a particular account, or the account that is actually deploying the contract will hold the initial total supply. The proof of stake actually comes into picture when you distribute that and start creating an ecosystem. So that's when, so proof of stake or proof of work, these are just underlying algorithms, right? Your community, your network is the one that implements those algorithms. So unless and until you have a network of peers who are connected to each other, there is no consensus protocol. There is no question of consensus protocol. So only when you have a network where people are running nodes, that's why every up and coming blockchain incentivizes you to run nodes. Because the more people run nodes, the more people are participating in the consensus, and the more and more your chain becomes decentralized, because more people are participating in consensus, more randomization increases, and then your decentralization becomes more and more powerful. So the power is not just with one person, it's split. And to split this, the more you, if you run nodes, you are incentivized, you get tokens. You maybe sometimes you need X amount of tokens even to run a node. For example, in the Ethereum 2.0 ecosystem, which is again based on sharding, right? Proof of stake. You need 32 ETH to become a validator. So you have to hold a certain stake. That's what it means by proof of stake. You have to hold certain stake to be able to participate in the consensus algorithm, right? So that's how you initially you have a total supply. From that total supply, you get some stake, right? You buy a couple of ETH or near or whatever, and you have certain stake which you can then stake and become a validator, run a node, etc. And then your proof of stake kicks in. That's when your proof of stake kicks in. All right. If there are no other questions, I think there was meant to be a break around 12 o'clock. I have finished 4 minutes before, so that's good. If there are any questions, please feel free to also unmute and ask.
Any questions? Otherwise, we'll go for break.
Hello.
Hello.
Hello. Yes, ma'am. Ma'am, it's a very excellent session, ma'am. Thank you so much. We understood about blockchain very clearly, ma'am.
Thank you. Thanks.
Ma'am, one question, ma'am. If we implement a blockchain using JavaScript or Java, which is preferable, ma'am?
Okay. There are several things when it comes to blockchain. Maybe I'll cover some of it in the next half if that's interesting to folks. You have an underlying chain, okay? That is your network. Now, creating your own network is one of the most difficult tasks. That's where you have now innovative things like Polkadot coming in, called para chains, which allows you to create your own chain that can talk to other chains. So Polkadot is like this big sphere where you have different small chains which are connected to each other. Now, to build your own chain, which is the blockchain, like this is one of the protocols that I talked about, which is its own blockchain. It's a layer one chain. To build a layer one chain, it's not just enough to know a language. It's need to know how the consensus, the underlying consensus work. You need to know how you would use cryptographic principles to build that consensus. You would need to know how your network would function, how you would how people can run the nodes. So multiple things, right? So this is not just like one programming language, it's an entire ecosystem that you're building. It's like you're building a mini version of internet, right? So that has so many components built together. So that's your blockchain. Now, when you build applications on top of a blockchain, that's where you can use you can write something called smart contracts, which encompass the business logic of that particular application that you're building. For example, build an application which is which facilitates decentralized voting, right? Um, a decentralized voting application. So to write this application, you can use smart contracts. Now, the smart contracts that you build will differ from layer one to different layer ones will have different languages. Now, the languages that you have mentioned, JavaScript or Java, Java is supported in couple of chains. That is, one public blockchain is Neo blockchain, supports Java. There is a private blockchain called Corda, which supports Java as well. There is another concept similar to blockchain called hash graphs. So there is a company called Hedera Hash Graphs that also supports writing logic in Java. From my knowledge, these are the only three that are supporting Java at the moment. To write smart contracts in other languages, I would prefer, if you have a good knowledge of JavaScript, you are able to learn the other smart contract languages very easily because most of them are modeled on JavaScript. Similar, but not the same, I would say. So for Ethereum, you have Solidity, and you have some other Viper and all as well. Solidity is most popular for building applications on Ethereum, loosely based on JavaScript. For Near, the one that I will be doing today, hands-on, there are two languages that are supported. One is Rust, which is becoming a very popular programming language for memory-safe applications. Another is Assembly Script, which is again loosely based on JavaScript. So most of them, if you are familiar with JavaScript, you are able to learn to write smart contracts in that particular language. So I would say if you're learning something or if you want to brush up on your skills, JavaScript would be the best option. But you're also free to learn other functional programming languages like Rust, which are becoming very popular for writing smart contracts. Like Near supports Rust, Polkadot supports Rust. So if you want to go into, these are both different, right? JavaScript is your lighter version, the client server side, and you have other functional programming languages or memory safe languages that are closer to your assembly language or closer to your machine. So I would say, like, if you have to choose between these two for an easy purpose, you can go for JavaScript. But if you want to go more and more from a computational side, want to build your own computational logic, want to go closer to the machine, then I would say go for Rust. Java, not so popular, unfortunately, this ecosystem.
Thank you, ma'am.
Thanks. One question is there around security in Near blockchain. So Near is highly secure. So far, there haven't been any attacks yet. Um, Primarily because there are two ways to secure a blockchain, right? One is you have the underlying algorithm itself secures it. That is, you have the blocks are hashed, you can't see easily, right? So that is one level of security. The other level of security is your network security, right? How many people in the ecosystem can you compromise, right? If you compromise 51% of people, then it is easy for you to have an attack, to do an attack, right? And this is where the Near ecosystem ensures that there are diverse number of people running the nodes across the globe. The community is split like literally all over the globe. We have people, ambassadors or folk validators running nodes from different parts of the world, which ensures that you can't hack 51% of the system very easily. So far, there haven't been any attacks possible on it. But as we are building more and more features, we are also building interoperability. Yeah, we'll see. Hopefully, I'm sure there'll be more security practices as well that will come into picture. If you're looking for a detailed security report, I'll see if I can connect with someone from the Near ecosystem and get